distance m stated in the time s. In this table, when the body time is 0, the body did not move. When the time is 1, the body moves to 2. When the time is 2, the body moves to 4. When the time is 6, the body moves to 6. When the time is 4, the body distance is 10. When the time is 6, the body distance is 12. When the time is 7, the body distance is 14. When the time is 8, the body distance is 16. When the time is 9, the body distance is 18. When the time is 10, the body distance is 20. From this table, you are asked to draw the distance time graph. B. Calculate the velocity of the car from the graph. Example 5. A body moves the distance m stated in the time s. In this table, when the body time is 0, the body did not move. When the time is 1, the body moves to 2. When the time is 2, the body moves to 4. When the time is 6, the body moves to 6. When the time is 4, the body distance is 10. When the time is 6, the body distance is 12. When the time is 7, the body distance is 14. When the time is 8, the body distance is 16. When the time is 9, the body distance is 18. When the time is 10, the body distance is 20. From this table, you are asked to draw the distance time graph. B. Calculate the velocity of the car from the graph. Figure 110 example shows that the distance is on the vertical axis while the time is on the horizontal axis. Then when the time is 2, the distance is 4 and it has to be traced to a point. When the time is 4, the distance is 8. When the time is 6, the distance is 12. Until the time is 10, then the distance is 20. They form a very straight line graph from the origin, having A, B, O as the slope. Solution. Velocity is equals to slope A, O, which is equals to AB over OB. Then the distance from AB is 16 meters all over the distance from OB, which will give us 2 meters per second. Rectilinear acceleration. Acceleration A is defined as the rate of change of velocity with time. Average acceleration is equals to velocity change over time, which is equals to final velocity V minus initial velocity U all over T, where U is the initial velocity and V is the final velocity. The unit is meters per second squared and the dimension is length per minute squared. In acceleration, we can say V2 minus V1 all over T2 minus T1 is equals to a constant, or the V over the T is a constant. Equations of motion. V is equals to U plus AT will be taken as our equation 1. S is equals to UT plus half AT will be taken as our equation 2. V squared is equals to U squared plus 2AS will be taken as our equation 3. Equations 1, 2, 3 are the equations of motion of an object moving in a straight line with uniform acceleration. Looking at the diagram, this is a velocity time graph. A body moves at a constant velocity from O to C. Then it now moves from C to B at a changing time. Looking at the diagram, we cannot trace the slope since the graph is now having an intercept from the velocity on the vertical axis. Then CBD we present x as our slope 2, while OCBA we represent our slope 1. From B to D is our change in velocity, which is final velocity v minus initial velocity u, while from B to A is our final velocity from A to B. From the velocity time graph above, the acceleration A is given by slope, which is equals to BD over CD, which is equals to V minus U over T, which is our acceleration A, where U and V are the initial and final velocity respectively. Final velocity making final velocity the subject of the formula, we have that V is equals to U plus AT, which is still our equation 1. S, or the slope, is the area of the trapezium OABC. So X, or the slope, is equals to half in bracket OC plus AB close bracket OA, which is equals to half U plus V, all in bracket times T, is equation I. But you know that our final velocity V is equals to initial velocity plus acceleration times time, which is our equation 1, equation II. Substituting II into equation I, we have that the slope, or the distance, is now equal to U plus AT all over 2 times T. Then the distance x of the slope is now equal to UT plus half AT squared. This is now be our equation 2. For the third equation, the slope is equals to area of a trapezium OABC. S is equals to U plus V over 2 times T by definition, but T is equals to V minus U all over T by making T the subject of the formula. S, we now substitute into we now have U plus V all over T 2 plus U minus V minus U all over A. Since V is equals to U plus AT, simplifying, we have V is equals to U plus 2AX. Alternatively, suppose the velocity of an object moving in a straight line with uniform acceleration A increase from a value U to a value V in a time T. Then, from the definition of acceleration, A is equals to V minus U all over T, from which V is equals to U plus AT. This will be our equation 1.